Hi everyone, I'm Julu Panan. I'm Principal Product Manager for Textract. I'm here today to talk about Amazon Textract and super excited to talk about a very new feature that we launched today called Textract Queries. So let's get started without any delay. From an agenda perspective, we're going to do a quick overview of AI ML at AWS. We'll discuss some of the issues with the legacy solution associated with document processing. And then we'll look at Amazon Textract's current capabilities. And then we'll dive deep into the Textract Analyze document feature, the new feature called Queries. And we'll do a quick demo and customer references and pricing, which you might be interested in. So this is our AWS AI ML stack. We are always innovating on behalf of our customers to deliver the broadest and the deepest set of machine learning capabilities for builders of all expertise. Our goal here is to remove the undifferentiated heavy lifting from our builders so that they can pursue the value-added differentiating features for their product. So the way I look at the AWS AI ML stack is this three-layer cake. Yes, three-layer cake it is. The bottommost layer is called the ML frameworks and the infrastructure layer. This is built for the great experts who want to delve into the machine learning frameworks, and they want to leverage, say, Amazon SageMaker in building these, or use AWS deep learning AMIs. And then you have the middle tier, the middle layer, which we call the ML services, and this is where Amazon SageMaker resides. And what we see here, or this is targeted for the customers or the developers who are experienced or who are data scientists, and they want to do their own model training and deployment at large scale. We've seen developers and data scientists who use SageMaker already see 10x the productivity by using this product. And then the top layer that we have is the AI services. Now, AI services is targeted to developers who have no ML experience, and they don't need to because they are focused on application development. And what AI services does is it's a managed service. And when you say managed service, we have built all the pre-built models which are tuned to solve the customer problems that you have, whether it is personalizing a customer experience or forecasting a business metric, or if you want to translate a customer conversation, or maybe even extracting information from data and making creating synthesis out of it. And there are many more use cases that our customers tell us. So that's where the AI service comes along. And that's where you will see Amazon Textract is one of those services which enables you to just call the API and be able to extract information from documents. So we always work backwards from our customers. We talk to customers in different industries, be it finance, insurance, healthcare, medical, legal, education, you name it. And in all of these businesses, what we have seen common theme is that document is the primary business tool across these industries, right? And you have to extract information from these documents in order to say what is next, what is the business insight, or what decision they have to make. So essentially, it is the common place for virtually any industry, and we have to find a way to process documents. So we talk to our customers and try to find out what do they do today. So there are three things that they do today. One is they use traditional OCR. And what traditional OCR means is that you extract information from documents and you get this raw text and data out of it. And when you get that data, you have to do a lot of post-processing to figure out, to make sense of the data, to say, okay, this is a name, this is a address, or this is a SSN. You have to do a lot of post-processing to get there. So customers, what they do next is, the second model that they do is, they build templates. They build templates that are very document-specific. And when it's document-specific, you can imagine there are a variety of documents out there, and there is no way for you to build a template for every document that exists, which varies slightly nuanced or maybe very different. And these are brittle. And also they're dependent on the OCR output. So if your OCR quality is not good, your template adding onto it doesn't really help. And the third thing that the customers do is use manual processes. Now, manual processes are done in the manner of having a human workforce doing a data entry. But we all know doing data entry means fat fingering a number. There is a risk associated where the data entry is done. Is it done offshore? Is it done in a secure place? Does the data leak out? So there are security, there is compliance, all these issues that you have to worry about. So this is what customers do today, and they want faster ways to do document processing so that they can shorten their document processing and enable faster decision, which in turn helps their customers. Then when you talk to CIOs and CAOs, right, and you ask them what are the challenges that they see in the business, well, document processing is one aspect of it, but in their mind, they're thinking about revenue. Like, how do I increase my revenue? And what they're seeing with the current document processing is that they're losing the revenue, right? And the loss of revenue is primarily because there is limited growth with the current systems. If you have to introduce a new template, that needs additional development time. And that means you're delayed in order to get that project funded and executed. So you're delayed in there. And so that's limitations. Also, there is inability to scale quickly, right? Like if you have a lot of documents that come in, new workloads that come in, how do you scale quickly? It's not possible without a big project. And there are barriers to transformation, right? There's resistance internally from operations team from doing something which is different for them. And the other dimension that you look at is the higher cost and risk. This is very important to our leaders, right? They want to make sure that staff is available for them to scale or not. How do you scale the team size so that you can process document processing? Adding more people means increased cost. And also, there is a chance, there's a risk of poor quality because you may end up fat fingering, or different people might have different views of how the data is represented. So there might be some biases on that. And there is technical debt, right? That leads to security risk, compliance risk, and lack of business continuity. And that's where Amazon Textract comes in. So Amazon Textract is a managed service that automatically extracts printed text, handwriting, and data from any documents. Now, Amazon Textract also goes beyond just simple OCR. It uses advanced technology of computer vision, natural language processing, and other machine learning innovations that we have built over years to get beyond what today's OCR technology does. So it does not just extraction of data, but it's also able to capture structured information, key value pairs, tabular information, the relationship of how data is represented within a structure or a layout. It's able to get that. And there is no ML experience required. So you can have your application developer just call the Textract APIs, pass in the PDF, or you upload it to an S3 bucket in AWS, or send in an image file of JPEGs or PNGs, and it will extract all the information from that document and will return you in a JSON format, which you can then just parse it and pass it to your downstream systems. And then when you do this at a large scale, you're lowering the cost. And the reason you lower the cost is the cost of running through Textract is minuscule when you compare it to a human data entry person doing this work, or trying to fund a project to create that new template that your business needs. And overall, we reduce the overall manual labor associated with it because we are automating the process for you. Now let's look at some of what our customers have been doing in various verticals and business outcomes. So let's look at financial services. We find customers trying to extract information from a lot of documents, whether it's pay stubs, bank statements, checks, you name it, right? They're extracting the information, getting insights, making business decisions, whether it's your loan application or whether it is your identity verification. There are many things that happen in that process. And then if you look at healthcare and life sciences, there are companies like Anthem who does life insurance processing, claims processing, and they also use the data that is extracted from from the document to figure out what next needs to happen here, right? And it's business insights or business process decisions that has to happen. Even in manufacturing and retail, we see them analyzing invoices, receipts, contracts, legal contracts, or many other things like warranties. They are using these kinds of documents to extract information, make key decisions, or inform businesses where they need to invest in future based on these trends. We also see in public sector customers using us, whether it is your IRS tax form. This is that time of the year where you're filing your tax. So, people are using in different industries Textract, and they are finding value. And the value that they find is, one is productivity, improved accuracy, process velocity, and reduction in cost. Second, they're improving the end user experience. That's because they are able to now do a data capture right there and provide that information right there to the user so that they can confirm if they need to, in case of an identity verification. If you take a picture of an ID doc, right, you get that information, they can confirm it. And it's improving the user experience through the speed of the service and improved availability of the service. It's there, like it's AWS, it gives you that backing. And then finally, decision-making. It improves the decision-making through richer interfaces and scales your business processes much more efficiently. Let's move on to see what some of our customers have been doing, and I want to show the business impact that has happened in the past. So Anthem, our leading healthcare insurance provider, right? They came to us, and their challenge was that they were spending millions of dollars trying to extract information from claim processing, claim documents, right? And claim documents come through emails with attachment, different kinds of attachments. They come with scanned documents or they're fax documents. And they have to get all these variety of documents, extract that information, the key information for them to make sure that this claim can be processed or approved. In order to do that, they were challenged. They were like, okay, I need to automate this process, and their innovation lab reached out to us, and we worked with them on Textract, and they used Textract to digitize and automate their claims processing. They basically use Textract to extract information from the document so that they can now make claims processing much easier, like an end-to-end workflow. And they're almost there. From an impact perspective, they have automated 80% of their workflow, and they're now striving to be 90% automated by the end of this year. Just to give you some frame of reference, Anthem, so data entry used to take 20 minutes to fill in an application, just data entry, plain data entry, 20 minutes. Versus if you use Textract, you can do it in few seconds or few minutes, depending on the workload. So that's the huge difference that you see from a customer impact perspective. Let's look at another one from a different industry. This is the mortgage industry, Black Knight, one of the top mortgage solution provider. They provide mortgage application solutions to various top banks, and they came to us saying like the COVID had hit, and they have seen an increased number of applications go up, and they were challenged on how to scale their business. And they decided to automate their system so that they can unblock the revenue opportunities that they were seeing. And what we did was, we looked at their loan processing workflow, and we looked at their documents, and the documents consist of different kinds of documents, like very varied. Bank statements, pay slips, W-2s, you name it, right? Like all credit reports. A variety of documents that change in layout, that cannot be predicted, can be faxed, can be mobile captured. And what we did was they started using Textract, and we were able to extract that information from them and give them in a key value pair so that they can use that information to streamline their mortgage loan processing workflow. And the impact is huge because now they're able to service a lot more customers in order to get there, right? So let's now look at Amazon Textract, what is generally available features, so that we just have to ground on what are the features available, and then we can go a deep dive into the queries feature. So Amazon Textract's capability today, as everyone knows, we are already providing extraction of text and data along with handwriting by using our Detect Document API. We also give you support for forms and tables. So if you want to extract information in a structured manner and you want to retain the relationship between the data that is extracted, whether it's in a key value format or a tabular structure, we have the forms and the tables feature as part of the Analyze Document API. Then we have the specialized documents. So customers came to us and said that there are a lot of complex documents, and the complex documents like invoices, receipts, or driver's license, passport. And they said there's so much business knowledge or domain knowledge in these documents that you cannot just apply OCR, apply forms and tables, because we do not know how the data comes in these documents. And so we would like for us for us to give them something which tells them like this is a business value, or it tells you like this is the information that you get from this document, right? A higher level abstracted value. And that's when we created Analyze Expense API, which will go into depth later. But Analyze Expense API was launched last summer, and it is focused on documents such as invoices and receipts. And then we have Analyze ID, which was launched last reInvent in December, and that is focused on driver's license and passport. And then we, of course, have the human in the loop. There are many businesses who want to audit the machine learned results, right, to make sure that it is doing its job. And two, some companies, our customers still need to run human review because it's required by the government or the regulators. So we also have that feature, which is natively integrated into our Analyze Document API. Let's dive a little bit more on the text extraction. So text extraction, or the Detect Document API, is optimal for dense text extraction, and it's the industry-leading OCR accuracy. So you can feed in documents such as like an email or letter or a book that you want to extract information into a Detect Document API, and it'll result in a block which consists of three things: page, line, and word. And with each word, you will also get a metadata which says if it's a handwriting or it's a printed text. So you can use that information if you want to route it to a human review. You can do so for extra verification. And all the words that are given back to you, you also get the confidence score. The confidence score enables you to also determine if you want a second reviewer in the process. And we also give you back the geometry. The geometry is important if you want to use that information to reconstruct. It gives you the relative positioning of the word in the whole doc. Next, we have the table extraction. So table extraction is extracting tables from documents, and it preserves the data structure and the relationship. You can use the Analyze Document API for it and the feature type tables. And when you pass that, you get out of it 3 blocks: page, table, and cell. And within each block, you will get a text, the value that it found, the confidence score, and the block's relationship. For example, a cell is within a table. So this information is very important for people who want to then take this into a schema, or you want to do some amount of post-processing, or you just want to recreate this whole structure in your HTML format. The next one we have is the form extraction. And the form extraction is used for extracting data from documents as key value pairs or preserving the document structure. This feature is available through our Analyze Doc API, and you just have to pass in a feature type called forms. And when you do that, you can pass in a doc, maybe like an application form, and you will see where there is a key value, there is first name, middle name, last name, and you want that association. When you want those association, you pass in the document and it get you that values back. So the API response consists of 2 blocks: the page and the key value set. And the page will tell you which page it was found. The key value set will give you like first name was John, middle name was X, last name was Doe. And so you will get those associations along with it. You will also get back the confidence score for each of those, which allows you to determine if you want to have a second pair of eye through a human review process. It also gives you back the geometry information. We'll switch gears a bit now. We'll go into specialized APIs. So I kind of spoke about it earlier where we said, customers want us to solve their problem for a particular document type just because it is a very complex document. So invoices is one of them, and receipts is another one. If you look at this document, the Whole Food receipt, nowhere it says that the vendor is Whole Foods. But customers need to extract that information that the vendor is Whole Foods. They need the vendor name. So the Analyze Expense API uses a combination of computer vision and natural language processing to figure out, what is the vendor name in this document, and it'll extract that information. It'll provide you a normalized key value which says vendor name is Whole Foods. It also will extract summary fields, like you would have the total amount or the subtotals that are there in the document. In addition, it can also get you the itemized list. The list that you see in this example is a piece of slice. It will get you that list. This is very important for our customers because now they don't have to figure out, hey, do I need to apply NLP models after doing OCR? That's taken care of. They don't have to worry about figuring out, should I use forms? Should I use tables? No, you just got the key value. The fields that are most important for you to process the document is given to you easily and quickly. So that's the benefit of invoices and receipt. Moving on, the next specialized API we have is for identity documents. Customers who want to do ID verification, or if they want to fill in an application form, come to us and say, we would love to get this information from ID docs. ID docs are the hardest. Reason being, one, it's got a very rich background, so it's challenging OCR by itself. The second thing being, these documents vary from state to state. We have 50 states in US. And so the challenge of getting these documents and the templates is even more challenging because they change every year, even slightly. So if you did do a templating, it wouldn't work. One, it wouldn't work because you would have a new version of a template maybe created next year, right? A real ID comes in, it's a new template that looks like, and you have to now spin up a new project on your end. Two, things have evolved. No longer, you're taking a faxing of an ID doc. You're taking a picture through your mobile phone. And when you're taking a picture with a mobile phone, your document never is on a flat surface. It can be angled. It can be, having a lot of light on it. And so there are very many variations on it. And so it becomes very challenging, even if you use a template design, because it wouldn't fit. And if it doesn't fit the template pattern, you wouldn't get good results. So our customers challenged us, like, how can we go and solve this problem? And so that's where Analyze ID comes in. And Analyze ID is supporting US passports and US driver's license for all 50 states, for all the versions of ID documents for the past 7 years. And it's a deep learning model, so even if slight new layout changes happen, it is able to understand it and make necessary modifications on its end or interpret it. It uses a combination of computer vision and NLP. Now, why do I say that? If you look at a driver's license, if you look at the address, there is nothing in there which says that this is the address. So if you had the 100 Main Street, Anytown, Massachusetts, there is no way for you to figure out that, like, humans can figure it out, but if you got an OCR output, there is no way that you could figure that out. So what Analyze ID does is it understands, okay, this looks like an address, right? And it's trained on ID documents because it's specifically shown these documents and trained on them. And it'll give you that value. It'll say address line 1, address line 2, city, state, zip code, all that information. Similarly, for the first name and last name, there is nothing in there which says it's the first name or last name, or it doesn't tell you that it was issued by Massachusetts. So all that information, we have taken out all the post-processing, all the custom models that you might have to build, and have packaged it so that you can just call our API and we'll take care of it. No need for any post-processing. And the benefit of it is, like, we are seeing 95% plus accuracy for the fields that we extract. You already get around 20 fields from driver's license and 8 fields from passport, which is a big deal for our customers. So now I'm excited about talking to you, and for which you have been all waiting, is the queries feature for Analyze document. This was the feature that we announced today at the keynote. This is an addition to our Textract family. So before we tell you what queries is, let me walk you through how did we come up with this product feature? What's the story behind it? And to tell you the story behind it is like we start talking to customers. We always start with our customers, and customers tell us like what is it that's troubling them or what would help them. And one thing that our customers said is like, when we ask them, what do you do after getting this data from Textract? What do you do after that? Post-processing, okay? Why do you do post-processing? How can we help? And the reason they said to us is like, we just needed 5 fields from a document, but unfortunately we have to extract all the information and then we have to do post-processing and then figure out these 5 elements from the document. This is a lot of work for our customers. And we said, okay, that makes sense. The other challenge that they had was data variation. You get documents from different places. They originated, they're formatted, they're structured very differently. And when that happens, you don't know how they label those fields. The fields might be labeled as SSN or Social Security number or tax ID or EIN. There are a lot of variations in there. And what customers end up doing is that they create a synonym list, which keeps track of all these variations, and they say, yep, SSN comes the same as Social Security, or if EID comes, it's same as tax ID. They have this synonym list. And this is a lot of post-processing. It's expensive, and it's time-consuming for our customers. Next, they told us is data structures. When they get documents from varied locations, they do not know where this information resides. Is it in a form structure? Or is it a free-form text somewhere in the document? Or is it within a tabular structure? They have no way. They're not looking at every document to figure that out, right? And so they have to now pass in both tables and forms and then do a lot of post-processing to figure out if it didn't come through forms, then it comes through tables or vice versa. The third thing is nested data. When I say nested data, this is essentially, imagine your application form when you apply for a loan. You have a borrower information, you have a co-borrower information. The borrower information, if you look at it, it has got the same information being collected, maybe your name, your date of birth, your SSN, and the same fields. The keys are labeled exactly the same, and it's there on the co-borrower section as well. And if you have to extract these fields, you have to do a lot of post-processing, and you have to use geometry to say like, okay, if it is on the left side of the document and the geometry fits in this line, then it's probably the borrower information. And if it is in the right side of the document, and if the geometry coordinates are here, then it's probably the co-borrower. It's a very template-like, but not templatized, right? A lot of post-processing in that space. And this means a lot of development, management overhead, creation of templates doesn't solve all the time. So all of these problems were told to us, and we were like, how do we solve this problem? We challenged ourselves. And that's when Amazon Textract Queries was built. Amazon Textract Queries allows you to easily specify and extract only the piece of information that you need from the document. It gives you that precise and accurate, high accurate information from the document. What you do is you pass in a document, the document from where you want to extract, and then you pass in a set of queries. The set of queries could be simple as, what's the patient's first name? Or what's the first COVID-19 vaccination date administered? Simple questions that a business user can also create. And we just need to make sure that fields are available on the document, right? And it can be, you can say, what's the Social Security or what's the SSN? It doesn't matter. We've taken care of that synonym problem that we talked about. And when it goes through queries, that's where magic happens. So queries uses a combination of models. It uses computer vision models, it uses NLP, it uses other innovations in our place, and it basically what it's doing is it's taking your textual cue, the textual cue that you're passing as in the request, it's taking that, and then it's looking at the document, understanding the visual cues around it. It's understanding the layout cues, the spatial cues around it, and then it's coming together to say that, okay, you're looking for the patient's name, and this is how I see it in the document. So it's a pretty innovative technology that the team has developed, and it'll give you that with high accuracy and high precision. The output will be whatever question that you passed, you will get those questions, the answers associated with it. You will get the confidence score as well. We will also get the geometry. So if you do want to have an application where you have on the left side your document and you want to highlight, this is where I found, you can use that geometry information to tie it there, right? You can also pass in the request an alias. The reason we gave the alias is a lot of our customers said, hey, we have to do this mapping back to the database schema. We said, how do we make it easier? Pass in the alias that maps to your database schema as part of the question. You get it back in the response tied along with the answer. So you just pick up that response and tie it back to your schema, removing as much possible friction from your development cycle. So it uses a combination of visual, spatial, and textual cues. It gives you a simple Q&A response, and it extracts only the fields that matter to you, and it's an easy integration. So you're using analyze document, you just have to change one parameter, a feature type called queries, and you will get this result, and pass the questions along with it. So let's look at some examples of challenges that our customers gave us. Let's look at mortgage ones. So mortgage one, this is a Fannie Mae form 1003. And if you look at that form, this is what I explained earlier. You have a section on borrower on the left side. You have a section on the co-borrower on the right side. And if you look at the fields, it's the same information that is being extracted, right? It's a date of birth, it's the phone number, it is your marital status, same things. But you need to be able to tie it back to whether it's of a borrower or a co-borrower. Very difficult problem today. A lot of post-processing that happens based on geometry. But with queries, that problem is resolved. You just have to pass in the question that you want. You just say, what's the borrower's date of birth? You can even say, what's the borrower's DOB? And it'll get you that information. What's the co-borrower's date of birth or DOB? And it'll get you that information. So you are getting high precision, high accuracy results from the document extraction. Let's look at another example in the mortgage side, bank statements. Everyone has seen a document, bank statement, and you will see, looking at this document, there's a section on the top which says your name and your address. Our human minds are geared that we can understand that. Looking at the document, we know right away that, okay, that's a name, that's an address. But what do you do today? Today you do the extraction with OCR, and then you do NLP custom models to say that if I find names like these, you have to train the custom model. That's another work. So you have to train the model, and then you have to find these things, right, of name and address. With queries, that gets simplified. As simple as just passing a question, what's the customer name or what is the account name? It'll get you that value. Or you have to say, what's a customer address or the account address? You get that value. So that's how we have tried to simplify a lot of our document processing for our developers and for you. Next one, pay stubs. So if you talk to any mortgage customers, I don't know if there are any in this room, but if you talk to them, they'll say pay stub automation, document processing is the hardest document ever. It is the most complex document because it has got tabular structures, and sometimes it doesn't even follow a pattern. In most cases, what our customers tell us is that they want to extract the gross pay this period or gross pay year to date to make that decision, right? Whether this person is having that much income as he claims. If they have to do it today, they have to do a table extraction, and then they have to do a lot of post-processing to figure out, basically triangulating your column header and your row to figure out, okay, this is the gross pay for year to date, and this is the current gross pay. A lot of post-processing. With queries, that's simplified. You just have to pass the question, what is the gross pay this period? Or what's the gross pay year to date you can do, or gross pay YTD. It's the synonyms work. And you get that value with high accuracy. Our customers loved seeing this experience, and they were like, this solves a lot of their problems. They are able to automate pay stubs, which is a very challenging problem for them. Now let's move on to an insurance-focused example, right? Common one, a health insurance card. How many times do you go to a doctor's office and you have to present this insurance card? And you want to extract, there are fields in there that need to be extracted so that they can do the verification. And with with Textract queries, it makes it easier. So in our example, our customers tell us that they want to extract like who's the insurance provider, or what's the member name, or what kind of plan type it is, because they need all these information to do that verification part of it, whether you're eligible for whatever health reason or tests that you're going to go through. It makes it very easy to use Textract queries in such scenarios. Another example is an accord form, very common in insurance space, right? It's the most dense document, a form like there are at least 100 plus fields in that document. But if you just want to extract 5 or 6 fields, I would recommend go trying out Textract queries for it. You can just pass in what's the program code, who is the underwriter, and it'll extract those specific fields with high accuracy. There are other examples as well where queries work, and I just wanted to bring that up. A COVID vaccination card. Every one of us has that now. So, this is the most challenging document that we have ever seen, and especially if this was put up during the emergency time. If you look at it, it's challenging because it's got forms and tables, great. But in real life, that's not how people enter data. If you look at the data, there's handwriting that goes across rows, across columns. If you look at, there's a sticker that goes across columns, and sometimes it's not even in the right order. So if you look at the first dose of vaccination, it has the lot number followed by the manufacturer name. And if you look at the second dose, it says Pfizer, which is the manufacturer, and then it has got the lot number. It's reversed. There is no way that a customer is typing things, or the person who wrote this up is writing it in the right manner. Then if you look at the date when the administration happened, the 2/8/2021, it's in the middle of nowhere, neither in the date column nor in the manufacturer column. And then you look at the site where it was administered, the NJH, especially for the second dose of vaccination. It's right in the middle of a date. If you use regular Textract and you extract, you get all this information, will do the best. But these kinds of documents end up with a human reviewer where they have to do the data entry. But with Textract, that gets solved. So with queries, you just pass in what's the date of the first dose of COVID, or what's the date for the second dose of COVID, and you will get that precise information because it is doing that thing that you are doing in your brain of trying to figure out how does this information, it's a date, I'm asking for a date, where is the date on it, where is the association associated with it. So it is doing all that work that a human intelligence does, and you get that result. While it can work in different types of documents, we've seen it, but we have also gone ahead and enhanced the quality of improved the accuracy and the quality of our extraction. We have trained our models on a lot of documents like mortgage, that's found in mortgage documents, insurance documents, checks, pay slips, you name it. We have tax documents. We have trained on many multitudes of documents so that you can get even better accuracy and find that. But we would also want to recommend that if you are using invoices or receipts or ID documents, we recommend that you use the Analyze ID or this Analyze Expense API because they are very much hyper-focused on those documents so that you can get the solution that you need. And you don't even have to write up queries in that case. It is optimized for those documents. So without further delay, let's go through a quick demo of queries, and it'll walk you through the different scenarios that I did, and then we can catch up. So let me play that.
Hello, and welcome to the Textract Analyze Document Queries demo that is also accessible from within the AWS Management Console. I'm going to get started here by simply clicking the Try Amazon Textract widget on the right-hand side of the Amazon Textract service page that can be easily accessed within the AWS console. Now you will see a number of preloaded sample documents here, starting with the sample vaccination record card. If you go to the drop-down below, you can see other examples of document samples such as pay stubs, loan applications, and healthcare insurance cards that we regularly encounter in our customers' environments, which is what we will be using for the purposes of the demo. If you like, you're of course welcome to upload your own documents using the Choose Document widget if you so prefer. With that, let's jump right in. To see queries in action, let's begin by taking the example of the sample vaccination card I have up on my screen. First up, you'll notice that under the raw text tab, Textract is already able to capture the text or the raw OCR output from this card, which you can segment at the line or at the individual word level, as shown here. You will notice that we accurately capture not just the linearly aligned text, but also slanted text, as is captured in the second dose sticker that has been applied at an angle on top of the vaccination record. Now, while the OCR output is a great start, this ultimately just represents a cluster of words or sentences, and customers would ordinarily have to write non-trivial post-processing logic in code to extract the data points they may be interested in, such as the date when the second dose of the vaccine was administered, for example, or even patient details such as name, date of birth, patient number, and others. This is why customers use our Forms product today, which can help them quickly extract labeled key value pair relationships, checkbox, and other relationships within text. Let's navigate over and see what the Forms output looks like just for reference. Now, as you can see, Textract is able to quickly and accurately extract fields such as the last name, first name, date of birth, and others that are explicitly labeled as such in the document. In addition, you will see that there's a table present in the document, and customers can also use our tables product to not only extract text from within tables, but also extract row level, column level, and cell level relationships within those pieces of information. Let's take a quick glance at what the tables output looks like. So you'll see here that Textract was able to accurately extract the table structure as was presented in the document. For example, it was able to capture the 4 different columns, starting with the vaccine name. It was also able to capture the 4 different rows across the first dose, second dose, booster, and other. You'll also notice that this is precisely where this document starts posing some challenges for extraction. And this is because of how the real-world capture of information on this document deviates from the expected canonical structure of the table. Specifically, you'll see that the second dose vaccine date and the clinical site of administration for the second dose has been captured under the manufacturer and lot name column. This is because of the sticker label that has been applied, which breaks the otherwise pristine geometry of tabular data. Customers tell us that they want to be able to simply extract the second dose administration date and clinical site without worrying about how this information may be presented, whether that's as a label, whether that's printed, or even handwritten text in the table on the screen. So given this, we asked ourselves, how could we make this type of extraction as easy as possible for customers? Working backwards from our customer needs, this was one of the key motivations for why we built the Queries feature, and I will now navigate to the Queries tab to demonstrate how this feature can really help customers. Now you'll see that we already have sample queries for demo purposes preloaded here. For example, you can see that we can pose natural language questions such as what is the patient name, what is the lot number on the first dose, who is the manufacturer for the second dose, and you'll quickly see that Queries is able to find the most suitable answer to those queries. And in fact, it's able to highlight where exactly in the document it found this information using bounding boxes. But in addition to these queries, I can also ask other types of questions. For example, I can ask what is the date on which the second dose was administered, which we know is a challenging extraction problem given the sticker issue I alluded to a few seconds earlier. So let's go ahead and do that. So I'm going to go to the search bar and I'm going to select the question which says, what is the date of the second dose? And I'm going to go hit the submit query button. So as you can see, once the result has finished processing, the Textract Queries was able to extract the second dose vaccine date accurately, even though it was misaligned with the table structure as we saw earlier. In similar vein, I can now go ahead and pose a query that says, what is the clinic site of the second dose, which is also misaligned. So I'm going to go to the search box and choose what is the clinic site of the second dose. I'm going to go ahead and submit the query. And if all goes well, it should be returning the CVS as the answer for the clinic site of the second dose, which it does. Now, I do want to point out that for demo purposes, the questions have been preloaded, but in reality, you can form all sorts of queries to extract the pieces of information you may be specifically interested in, depending on your use case, and we'll see an example of this shortly. But before we do that, let's now take a look at another idiosyncratic aspect of this document. If you take a closer look at the first dose line of the table, you will see that the information is actually presented out of order for the manufacturer lot name column. Whereas the table structure expects the first entry in this column to be the manufacturer name, which should be Pfizer, followed by the lot number, which is the AA1234. In reality, the information is presented in the reverse order, and the lot number comes first, followed by the manufacturer name. One of the other benefits of Textract queries is that it can actually disambiguate this discrepancy and still be able to capture the right information that customers are looking for. So for example, if I now go ahead and pose a query that says, who is the manufacturer for the first dose? And then go ahead and hit the submit query button, we'll see that it's actually able to correctly return Pfizer, even though the information is presented out of order. As I mentioned earlier, I'm not just confined to the pre-populated queries. I can pose a question of my own in free text. So for example, I can type a question that says, what type of a document is this? And I'm going to type this question in free text, hit submit query. And once it loads, you'll see that Textract automatically grabs the title of the document as the most appropriate answer for my query. Now let's look at a different example. I'm going to go ahead and choose the loan application sample to illustrate a slightly different use case for queries. So while the document is coming up, you will notice that under the section of the document titled Borrower Information, there is a cluster of fields containing information about the borrower, such as the social security number, home phone, date of birth, etc. You'll also notice that on the right-hand side, there's an identical set of fields that have the same exact field names that incidentally correspond to the co-borrower if there is one on the application. Now, let's imagine the scenario where the customer specifically wants to extract the borrower's date of birth and social security number. For reference, if you look at the forms output, you'll see that this information does get correctly extracted. So the borrower's social security number is extracted using the forms API. However, it's difficult to ascertain whether this information belongs to the borrower or the co-borrower, as again, the key names for these data points are identical, and what's missing is the hierarchical context under which this information is presented. However, using Textract queries, queries is able to understand and apply the hierarchical nature of information organization within a document and allows customers to easily extract nested data points and get the specific data points of interest. So to illustrate this point, I'm going to go ahead to the query section, and I'm going to pose a question that asks what the borrower's social security number is. So I'm going to say, what is the borrower's SSN? And then I'm going to go ahead and submit the query. So as you can see, Textract is able to correctly grab the borrower's social security number in this case, even though both the borrower and co-borrower's key name is the same. By the way, you can apply the same logic here to extract the borrower's phone number or other pieces of nested information, even if the key names are identical across the different sections, as is the case for majority of the entries here. You'll also note that in the question I posed, I used the acronym SSN instead of spelling out the precise representation of the key value I'm interested in. But Textract was able to automatically map the key name social security number on the form to the SSN keyword in my query, which customers tells us saves them having to write lots of post-processing code for normalization, as queries is able to seamlessly handle these variations. All of these makes queries a very flexible AI-powered tool for intelligent document extraction. Now, switching gears, let's take a look at a pay stubs example. First, let me orient you to the document itself, as the layout is a little bit complex. So At the top of the pay stub is an earnings statement, which lists the total gross pay across different line items such as regular, overtime, holiday for the most recent pay period, as well as year to date. There's also information on different payroll deductions such as income tax for federal, social security tax, Medicare, state tax, etc. There's also a list of other benefits and information on the right-hand side. And then finally, at the bottom, there's a check that has been issued in the amount of the net pay information on the top half to the document. So now I'll navigate to the Queries tab once again, and you'll see that I can ask questions such as what is the year-to-date, abbreviated as YTD gross pay for the current period, which Textract is able to accurately extract. And you can see the bounding box information indicating where Textract found these pieces of information. But now I can start to pose all types of other questions. So for example, I want to be able to extract the total to date group term life. And so I'm going to go ahead and submit this query, and Textract will be able to correctly extract this information from the right-hand side of the document. In addition, customers may want to know what the employee's address is, as well as the company address, and note that there are no explicit labels on the document itself that suggest which address belongs to which part of the document. But using Textract, I can write a query to extract this information accurately. So for example, I can pose a question that says, what is the company address? Go ahead and submit the query. And it's going to find the address that most correspondingly associated with the company information. Similarly, I can specify or ask what is the employee address, and it will go ahead and try to grab the employee address. And again, the key thing to note here is, there are no templates here. Pay stubs can have any type of a format. There's no preset layout. And using ML and the flexibility of AI queries makes it very easy to extract all of these different pieces of explicitly as well as implicitly labeled information from documents such as a pay stub. Now let's switch gears again and take a look at a healthcare insurance card example. So you will notice that I can automatically, using queries, I can automatically extract the insurance provider name, which is Anthem in this case, which is what we call an implied field because there's no explicit label called issuer or provider that could be used otherwise to derive this information. In similar fashion, I can query the plan type, and Textract is able to return the most likely answer, which is the Pathway X EPO label at the bottom of the card, even though once again the information is entirely implied. So this then brings us towards the conclusion of this demo of the Textract Analyze Document Queries feature. To recap, we saw how the queries feature that is now generally available is able to provide customers with unmatched intelligent document extraction flexibility by letting them specify the information they seek from any given document or a set of documents and return that data in question-answer based response structure. We saw examples of powerful, highly flexible natural language-based queries that we posed to extract some of the most complex data points from several real-world documents, such as a vaccination card, a pay stub, a loan application, and an insurance card out of the box quickly, easily, and accurately. As we saw, customers can simply specify the data they need from the document without worrying about how that data is presented in the document, for instance, whether it's present in tables, forms, within nested sections, or even as implied fields, or variations across document versions and formats. Queries has been pre-trained on a large number of structured, semi-structured, and unstructured documents, and is designed to work on any type of a real-world document without the customers having to acquire any machine learning experience or expertise to get started. We believe this feature enables intelligent document extraction on some of the most complex and challenging document types, such as pay stubs, bank statements, loan applications, vaccination cards, and others that are important to our customers. And we are very excited about how customers can use this feature to improve their business process productivity, reduce cost, and serve their end customers in turn faster.
Okay, so I'm sure this has piqued some interest, and when you are out of the space, you probably want to go and head to our AWS Developer Console to try it out on your documents, and we would love to hear your feedback on it. But in the interim, we had run a private beta where we gave early access to some of our customers, and they tried it out. And we have few customers such as Bobby Land, from the chief technology officer from Envase Technology, who used it and really loved it because he liked the idea of not having to come up with specific names, right? Like the synonym aspect of it. And it worked out of the box for him. So he was a happy customer. We also have Rob Jansen, the Chief Executive Officer from Textract, letting us know that it helped them being able to improve their productivity because they could extract very specific fields from the documents. And then we also have Thorsten Warneck, Principal Head of PC Analytics from Camelot Labs from Europe. And they tried it on their European documents, and it helped them improve the quality of information extraction and unlock a lot of IDP opportunities for them. So, I know this seems very interesting, and you probably want to know next is what's the price for this future. And so queries is bundled along with analyzed documents. So you can use queries alone, right? And we have tiered it similar to analyzed doc features, forms and tables. So there is a tier for the first 1 million pages, and then there is tier 2, which is for anything above 1 million pages. And the way we have structured is that it is going to cost you $15 per 1,000 pages. And if you use our sync APIs, you can send up to 15 queries per page. And if you decide to use our async API, which is our batch processing, you can send up to 30 queries per page. And if you decide to go more than 1 million pages in a month, then you would be having a price of $10 per 1,000 pages. And the same query limit exists. Now, we have also seen customers who want to combine queries along with tables. And they do that because they probably need like bank statement, right? You need this name, address, and some other fields like ending balance, beginning balance. But they also need the account activity table, right? The transaction history. And so they want to combine tables and queries in one API call, and they can do that. And for that, you can give, you will get $20 per 1,000 for the tier 1 and $15 per 1,000 pages for the tier 2 for anything above 1 million. And then we also have customers who want to combine with forms. And if you do that, then you are charged $55 per 1,000 pages for the first tier and $45 per 1,000 pages for the second tier. And there are customers who want to combine all of them because they probably want all the data for their analytics or passing it information to a data lake so that they can do behavioral modeling. But they probably need the 5 or 6 elements only for real-time processing, where they probably want to make a decision whether the loan application is approved or not. For those customers, if they do this bundle, then you are charged with $70 per 1,000 pages for the tier 1 and then $55 per 1,000 pages for the tier 2. And that's a combination. Now, I'm sure you want to get started or you want to start reading about it. The best place to get started is our Amazon Textract service page. You will have the links on there to get directed to the console where you can upload your own document and try it out for yourself. We also have published an analyzed document queries blog that went live today. So please feel free to check that in because it'll give you step-by-step guide on how to call the API, how to get the data. There are sample documents in there. There are also sample queries out there for you to get started so you don't have to figure it out on your own. Make it simple for you. And then you have the GitHub repository. So all the code samples are out there for you to download and try it out on your end very quickly. So we want to make sure that you have a very quick start. And lastly, we encourage our customers and developers to continue to increase their learning and learn by our AWS Cloud Skills. There is the AWS Skill Builder program that allows you access to 500 plus free digital courses. There is also the AWS certification if you want to go to the next level and be industry recognized. This is one of the ways to do that. and you get to join the AWS certified community with exclusive benefits. In order to get started, you can get started with scanning this QR code, and it'll get you directed to how do you get access to these things. Lastly, so I had fun presenting this topic, and we covered a large variety of topics, right from the AI ML's AWS stack. We talked about Textract. We talked about the forms, tables, OCR, the challenges associated with it, and finally queries. Like we did a quick demo on it to see how this would help out in your business processes and streamlining it and removing the cost and the operational burden that comes otherwise. So my name is Julu Panat. If you want to reach out to me, my email address is listed below. It's julup@amazon.com, and my LinkedIn profile is also here. So would love to answer any queries. And last but not the least, there is a session survey. So if you are able to complete that, I would really appreciate that.